Hello, students. Today we're going to talk about linear functions once again, but this time we're going to actually be writing the equation given information about maybe some points on the line or maybe the slope or both. We're also going to talk about horizontal, that's straight across lines, and vertical lines, straight up and down lines, and what those have to do with. And also parallel and perpendicular lines and what is true about those. So let's get right to it. All right, just a review of graphing here. It says graph the following lines in y equals mx plus b form, that's slope-intercept form. So you always use this number first. I'm going to go down one, put a dot, that's your y-intercept. And then your slope is the number in front of the x. In this case, it's 2. So we have the slope is 2 over 1. I'm going to write it as a fraction because slope is rise over run. It's the angle of the line. So we're going to start at the -1, and we're going to go up to, and we're going to go to the right. Always go to the right if you want to be right, is what I like to say. So there is the second dot, and then you can keep going up 2 over 1, up 2 over 1, and you get a bunch of dots that all line up. There, I graphed the line, and it was in y equals mx plus b form. Let's take a look at this next one. It actually has a fraction there already. Don't panic. That's simply the slope. M equals 2/3, and your b value, y equals mx plus b, your b value here is 2. Now remember, that's the y-intercept. So I'm going to use that b value first and go up to, put a dot. And then from there, I'm going to use the slope. From there, I'm going to use the slope to get the second dot. So I go up to, always go to the right if you want to be right. So I'm going to the right. And there is my second dot. And I've graphed that line. Now, I want you to notice that both of these lines were up and to the right, and that was because it was a positive slope. However, this next example is actually a negative slope. So this one is going to be a downhill line, actually. We're going to go up 3, put a dot, and then this slope is -1/2. So we're going to start here, and we're going to go down 1, and then remember I said always go to the right if you want to be right, and we want to be right. So our second dot would be down 1 over 2, down 1 over 2, down 1 over 2. You see how it maps out a line that's actually downhill this time, and that was because the slope was negative. So that's just a review of how to graph y equals mx plus b. Now, writing an equation given information means we need to plug in our m and our b. But you know what? Neither of those were given to us, so what can we do? We can figure them out. We can calculate. So we know how to find the slope, don't we? The slope between 2 points is where you subtract the y's, delta y is another way of saying that, subtract the y's, find the difference of the y's over the difference of the x's. So I'm going to subtract the y's because it's wise to start with the y's. 10 minus 12 all over 4 minus 6. That's -2 over -2, which simplifies to what? 1. So it turns out our slope, which is the letter m, is 1 in this problem. So remember, we are trying to write our answer y equals mx plus something. So we just figured out that the slope is 1. I can just literally plug that puppy in there. Now, what about the b? We want to figure out the b next. Well, so let's write down what we do know. We know this. Y equals 1x plus b in this problem because we figured out m is 1. Now, if only we knew an xy combination, we could plug it in right here and here. If we knew an xy combination, in other words, an ordered pair. We have them. We have 2 of them, actually. So I usually pick the one with the smaller numbers. So I'm going to plug in 10 for y and 4 for x. Where am I getting those again? Right here. 4 goes with 10. When 4 is x, y is 10. So I can plug that in. That's not 1.4, by the way. That's 1 times 4. So 10 equals 4 plus b, solving the equation. We minus 4 on both sides. 6 is B. So I didn't actually graph it. I didn't go to Desmos to figure out where the y-intercept was. I actually used a little bit of algebra and substitution to solve it. And I simply plug that in, plus 6. Our final answer to the question, write the equation. The answer is y equals 1x plus 6. Now that wasn't too bad, was it? All right, now, actually before we do that, I want to come down here and say, what is the equation of this line here? Because once again, we want to write the equation of the line. But this time, instead of giving a couple points, I gave the graph. Now, our answer is going to be y equals something x plus something. We got to figure out the slope and the y-intercept. Now this problem's much easier than the last one, friends, because first of all, the y-intercept is painfully obvious. B is -2. So we could actually just plug that puppy in right there. And then the slope is also pretty easy to find, isn't it? Because I see a point here and a point here. The rise and the run looks like it's up 2 over 1. Up 2 over 1. So we could put that in there like that. That could be our answer. Or if you want to write it as y equals 2x minus 2, that would be fabulous also. All right, so you could write an equation given a couple points or in a graph, and it's fairly straightforward. All right, now these are some special cases. Horizontal lines, graph a horizontal line. All right, here's a horizontal line. Boom, like this. All right, this is the y-axis, this is the x-axis. Now what is true about this? This has a slope of 0. It has a slope of 0, and I want you to notice that this goes through y equals 3, right? Right here is y equals 3. Well, you know what? That's actually the equation of the line. Also, y equals 3. And that's what the notes say here. Horizontal lines always are of the form y equals something. So in this case, the answer here would be y equals 3, and I want you to also notice that the slope is 0. Vertical lines. Let's draw a lovely vertical line. Here we go. Boom. There's a vertical line. I want you to notice it goes through x is -2. In other words, x is always -2. If you're on this line, x is always going to be -2. So that's actually the equation of this line. X is -2. And by the way, the slope is called undefined. It is so steep you can't even describe it. It's undefined, we say. Okay? So there you have it. Vertical lines are always of the form x equals c. We already did that, so good for us, right? One last little review from Algebra 1 here. Parallel lines look like this, right? They go at the same angle. They're always the same distance apart. They never hit. That's what students always say. But what else is true? They have the same angle, so therefore they have equal slopes. Makes sense, right? But I want to point out they have different y-intercepts. So the purple line hits down here. The red line hits up here, which is fine. They are parallel. They have the same slope, but their y-intercepts are different. So this line might be y equals, I'm just making up numbers here, 2/3 x plus 3, while this one would be y equals 2/3 x. See how they have equal slopes there. But then this one might be -2 because, see the y-intercept, it's down, maybe down 2. I'll put my hash marks in there just to make you happy. There you go. You see, there's the equation of two lines, and they happen to be parallel, and I know that because the slopes are the same. All right, this is the tricky one, perpendicular lines, and I can't actually move this over, unfortunately. Well, I might be able to. Let me try this. There we go. Does that work for you? Perpendicular lines look like this. They form a 90-degree angle. Perpendicular lines have a 90-degree angle. Now, I've drawn perfectly perpendicular lines, believe it or not, and let's see if we can discover what's true about their slopes. The red line here is up 2 over 1. So the slope on the red line is up 2 over 1. Now, what about the blue line? Is that a negative slope or a positive? Well, it's downhill. Remember we said that downhill lines are always negative slopes. So this line is actually down 1 over 2. So the blue line has a slope of down 1 over 2. All right, so those fractions have some things in common. Do you notice that? They both have the number 1, they both have the number 2. They're both fractions. Okay, so that's good, but now what's different? They are flipped over and different signs. They're flipped over and different signs. So the fancy way of saying that is perpendicular lines have opposite. That has to do with the flipping of the sign, right? The changing of the sign. They have opposite signs, but also reciprocal. Opposite reciprocal slopes. A lot of students accidentally just flip over the sign, flip over the fraction, or maybe they just change the sign. You got to do both. You got to flip it over and change the sign in order for two lines to be perpendicular. Now, this particular drawing, this is not always the case, but the way I drew this here is they actually have the same y-intercept. That's not always the case, but it can be. So this line is y equals 2x minus 1. You see it hits at -1 right here. It hits at -1 on the y-axis. Whereas the blue line is y equals -1/2 x minus 1. So they both happen to have the same y-intercept. That was just an accident here. That's not always the case with perpendicular lines. But I do want you to notice that the red line has a slope of 2. The y has, let me make sure you guys can see that, it's a -1/2 slope. So the slopes are the things that are going to be different, but they're not just going to be randomly different. They're going to be opposite reciprocal slopes. All right, so you are now ready for 4.4. That's all the material. Again, this is a review from Algebra 1. So hopefully I did a decent job reviewing it for you, and you can start to think about tackling an assignment. All right, take care. Good luck.